Which of the following sets of data is best described by a linear model? Right here, if we look, we can see that in B, the y value is going down by 1. We can see right here. And the x values are going down by 2, so it's constantly changing. The x values are going down by 1, the y values are going down by 2. Part A is being multiplied by 2. That's not linear, that's exponential. Part C is divided by 2. And then this part is a quadratic because it has a second difference. And so when you have a second difference, that's quadratic. Which of the following models best describes the data set? Alright. It looks like right here, it's going -1 for the y value, +1 for the next one, and +3, and then so the second difference is +2 +2. As we just said, that's a quadratic for the second difference. Which kind of model best describes the data graph below? And it's exponential because it's a curved line. As we notice, you see it curving and has an asymptote here. Y equals 0. Which is the average rate of change over the interval 0, 2? For equation A, which has a table listed, and equation B, which is x plus 5. As we look right here, my average rate of change for the first one, I use my slope formula. I have my y2 and my y1, my x2 and x1. I have 4 minus 0 and 2 minus 0. 4 divided by 2, which is 2 for equation A. So that gives me 2 choices there. Now on the second one right here, I know that my slope is 1. So my slope is 1, it's a constant rate of change, so it's always going to be 1. Even if you divide it by larger numbers, it's still going to reduce back to 1. So the answer is 2, 1. Alright, f of x equals 2x squared plus 2, and g of x equals 2 raised to the x plus 1 plus 2. Our graph on the grid below for what values of g of x are greater than f of x. Right here, as we can see, g of x is greater than f of x from 0 to 2, not including 0 or including 2. And g of x is greater up here, or at 4, so not equal in 4, but greater than 4. So there's only a little section where f of x is greater than g of x, and that would be right here. In which of the following situations does Michael's salary change at a constant rate relative to the year? Alright, so right here, Michael's starting rate is 9,500, increased by 4% each year. That is exponential increase because it's exponentially growing by 4% each year. The next one is $500 each year, so that's relative to the year, and that would be our equation for our linear, which is a constant rate of change. Alright, and the next one is $600 one year, or $500 one year, $600 next year. That's not constant. It's increasing by 100, but every year. Michael's starting salary is $9,500. He sees 4% raise one year and 5% the next year. It's increasing percentages, which makes it exponential. So the only one that's going to work is B. A has $1,000 in his savings account. He wants to save more money. He's looking at 2 investment plans under Plan A. He will increase his account balance by $200 a year. Under Plan B, he will increase his account balance by 15% each year. How much more will he save with a Plan B after 10 years? Right here, Plan A, there's our equation. 200x plus 1,000. So plug in 10, we get Plan A has 3,000. Plan B is y equals 1,000. 15%, so it's going to be 1.15 because that's a growth rate. Raised to the 10th, which gives me 4,046. Subtract those, you get 1,046. Number 8, given the functions g of x, f of x, and h of x shown below, the correct list of functions ordered from greatest to least by average rate of change over the interval 0 to 3 is, we'll look right here, the rate of change for g of x. I plug in 0, I find that 0 is 0, 0, and 3 would be 3, 3 after you plug it in. I do my slope formula, and I end up getting 3 over 3, which equals 1. So g of x is 1. The next one I do from 0 to 3 will be 1, 7. So 1 to 7 is 6. From 0 to 3 is 3. 6 divided by 3 is 2. Alright, and then the last one, I go up 9 over 1. I got 3, 9, and I have 1, 2 for my, or 0, 2. So that's my x1, y1, x2, y2. So 9 minus 2 is 7, and 3 minus 0 is 3. It gives me 2 1/3. So it's h of x, which is the greatest, which is 2 1/3. F of x, which is the middle, which is 2, and g of x, which is the lowest, which is 1. So it's D. Next one, the table below represents the function f. The equation that represents the function is, right here, it's f of x equals 2 to the x plus 1. I plug in my values. I plug in 3, 2 to the third plus 1 is 9. Notice that gives me 9. I plug in 4, 2 to the fourth is 16 plus 1 is 17. 2 to the sixth is 64. 64 plus 1 is 65. So notice it works out for each one. And notice that 9 times 2, excuse me. Yeah. Alright, as x increases without bound, which of the following eventually exceeds the function values of all the others for the same values of x? It is the exponential function, because exponential functions will always exceed quadratic and linear. And which expression is the coefficient of the n term 1? Right here, if we look at part D, it says plus 1 in front of n, or plus n, so there's a 1 in front of every variable that doesn't have a number in front. So that is 1. You look at C, that's negative 1. B is 5, and A is 4. So the only one that makes sense is D. 12. Look at the graph of the functions h of x and p of x. Which transformation of h of x and p of x translate each function so both pass through the point 0, 1? So we look at these graphs right here, and we notice if I shift this one down, I'm going to get 2 to the x, which moves it down 1. And then right here we have it on 0, so I need to move it up 1. So we move that up 1, they both get on 0, 1, and you look at our graph and see. If I move the quadratic up 1, it's going to be at 0, 1. If I move the exponential one down 1, it's be 2 to the x. So this one would be x squared plus 1, because I move it up 1. And the exponential would be 2 to the x, because it moved it down 1, where the asymptote is y equals 0. Which function has a range of f of x is less than or equal to 3/4? And the answer is negative x squared plus 3 to the 4th. And the reason it's negative x squared because it needs to be turned upside down, because that will make the range be less than 3/4. And 3/4 is our maximum point, so that would be 3/4 at the top of our graph, and that's our maximum point. The negative causes it to flip over and be less than or equal to.